Okay, going to talk about sets today. We talked about before, we're going to introduce a few more concepts. This is section 2.2. We're going to learn about these three things. I'm going to do a Venn diagram just to introduce what's going on. I'm going to have set A be what we call the universal set, which is all the elements that would be in the set. I'm going to let this set be letters of the alphabet. So we know the cardinality of A is 26. We know our 26 letters. So with the Venn diagram, we may have something like this. I need another set. So I'm going to say B is A, E, I, O, U, the set of vowels. So what this would look like, A would be this universal set, the letters of the alphabet. B lives in here. It's some of the letters. But it's not all the letters. There's a whole bunch that live out here. This part is called the complement of B, and we do it with a little apostrophe, I guess that is. So we have the set B, and its complement is everything that's not in B, basically. So just did that, only now they're doing universal set as U. So what they're doing, same picture I just did. U is here. Here's A. Everything outside of here is the complement of A. Now, I don't know what happened with my symbols here, but we've got, there's my universal set, those numbers. If I want to find the complement of S, it's everything that's in U that's not in S. So it would be 1, 3, 5, 8, 9, and 10. Hey, I got the right answer. I'll let you do the other ones. So this is more theoretical than anything. But if you have a set U, what this is saying, the universal set, since it has everything, its complement would be the null set or empty set, because its complement would not have anything in it, because U has everything in it. And just did that. Subsets. Hey, there's a set of vowels. So every element of vowels is in the alphabet. So we can say that the vowels are a subset because we can see here every element of the vowels is an element of the alphabet. So they're just, think of like smaller sets inside of bigger sets. This is the notation we use. So like we just did, if I did set A was alphabet, and I said set B was the vowels. Hey, let's do B instead of B. Why not? Then we can say that V is a subset of A. Not quite a C, more of a little something. So like part A, that should be, is it a subset? Well, let's see, 5 is in there, 10, 15, and 20. So yes, it's a subset. That's true. Are the whole numbers a subset of natural numbers? Well, remember the whole numbers are 0, 1, 2, blah, blah, blah. The naturals are 1, 2, 3, blah, blah, blah. Well, let's see. No, this is false because 0 is in here and 0 not here. 0 is not an element of n. So the wholes are not a subset of the naturals. Okay, I've already done Venn diagrams because they're just a nice, easy way to look at sets. So if we quickly think of it, there's universal. All this stuff out here, that's a complement of A. Stuff that's in a universal set that's not in A. Proper subset. The reason we do proper subsets is because of this. If I gave you a set A, 1, 2, 3, and I gave you the set B, 3, 1, 2, well, we would say, hey, B is certainly a subset of A because there are no elements in B that aren't in A. So what we do here, we can clearly see in this case, B is equal to A. They contain the same elements. So yeah, B is a subset of A, but sometimes we want a proper subset. So let's say C is the numbers 1, 2. Now, oh boy, C is a really bad letter. D, D is a proper subset of A because every element here is in A, but D is not equal to A. Hopefully there's a Venn diagram on this soon. Okay, these are equal. This set equals this set. So yeah, that's a subset of A. Now, n, the natural numbers, is all contained in the integers, but there's like the negative numbers and 0. So n is a proper subset of the integers. Okay, I don't want to go through this. Really what I want is, before I do this, I just want to look at, if I had universal set, a big set A, and in here I had a set B, we would say B is a proper subset of A because all the elements of B are in A, but there are still some elements in A that are not in B. If it looked like this, suppose this is A, and then this was B, just, hey, the same set. Well, then we would say B is a subset of A, but it's not a proper subset because there are no elements in A that are not in B. Okay, number of subsets of a set. I just want to get to the formula. There it is. I'm not going to worry about deriving it. If say A has 5 elements. So the cardinality of A is 5. Then there are 2 to the 5th, 32 subsets of A. These include A itself and the null set. Those are always subsets of sets. So let's think of a restaurant that's serving pizzas. They've got so many different toppings. I think we're going to use n equals 7 toppings. How many different pizzas can they make? Well, that would be the number of subsets, because maybe somebody only wants 2 toppings. Maybe somebody wants 5 toppings. Maybe somebody wants no toppings, or even all the toppings. Well, we can quickly see that the number of pizzas is 2 to the 7th. Let's see, 128. So they could make, if they just have 7 toppings, 128 different pizzas. And that's pretty much all the stuff in this section.